Hey, welcome to iFlip for Math, Mathcast, Lesson 4-5, Part 2, Dividing by One-Digit Divisors Using Doubles Division. I'm Mrs. Gooding, and our quote today is by Albert Einstein again. If at first an idea isn't absurd, there's no hope for it. This is going to be kind of crazy for some of you. You've learned division using the standard algorithm, and it's going to be a big adjustment to step outside that box of what you know and try something totally new and a little bit crazy. Our learning goal today is to use the doubles division strategy, or what we call the crazy way of dividing, to divide by one digit. So our learning goal, we have just one today, is to use the doubles division strategy to make dividing by one digit super easy. It is going to be crazy. Our vocabulary is doubles division. Doubles division is a division strategy where the divisor is doubled several times to divide without using multiplication. Your parents aren't going to get this at all unless you teach them how to do it. It's that out there. Here's an example. We're going to use the crazy way to divide 469 by 5. So I've written it just the way we always do. 469 is the dividend, it's in the house, and 5 is the divisor going into the house. But instead of starting out with how many times 5 goes into 4 or how many times 5 goes into 46, we're going to do something called doubling. So we're going to write a 1 here. That's how many times 1 times 5. And then a 2, we're going to double that, so it's a 4, double that, so it's an 8. So now we're going to double 5. So now we've got 10, and 10 and 10 is 20, and 20 plus 20 is 40. So this is the same thing as saying 1 times 5 is 5, 2 times 5 is 10, 4 times 5 is 20, and 8 times 5 is 40, but you see that I just set it up without using any multiplication at all. I just added 5 plus 5 is 10, 10 plus 10 is 20, 20 plus 20 is 40, and added this. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8. It's just this whole big doubling step. And once I do that, I'm ready to begin. It's really hard for me to draw straight lines tonight for some reason on the bamboo tablet. When we start looking at this number in the house, we're going to start the same way in what number right here is closest to 4 without going over, and we don't see any that aren't above 4. So we look at 46. And I want you to look at the 46 without looking at the 9 at all. Pretend like that 9's not there. I can't cover it up with my hand, but pretend like it's not there. So we're looking for the closest number that will go into 46 without going over. And we go down this list of doubles, and 40 is the closest to 46 without going over. So I write 40 right under 46 because I'm not looking at the 9 at all. Now I take this 8 that's next to the 40 and I write it over here, just like this, far enough away that it's not going to get mixed up in those numbers. Then I have an empty place value position here and I want to make sure that I fill that up, so I put a 0 there. And anytime I have to add a 0, I add the same number of zeros to the number I just wrote over here. So I have a 0 here, but that wasn't something I had to add. That was already in my doubles number. So I just add this one that I put in here over here. And now I'm going to subtract. 9 minus 0 is 9. 6 minus 0 is 6. And 4 minus 4 is 0. I'm not going to write that. I don't want it to confuse me today. Now I'm looking for the closest number to 6. Now I could look at 69 altogether. 40 is closest to 69, but it's not very close to 69. So watch what happens when I look at just the 6. The closest number to 6 without going over is 5. And I'm going to write that right here and take that 1 that's next to it and write it over here. Because I have an empty place value position, I'm going to put a 0 here. And because I put that 0 there, it's annexing a 0. I'm going to annex a 0 over here. Now, like I said, I could have solved it using this 40 underneath here, and it would have worked. There's a lot of different ways you can solve this problem using this strategy. you kind of can't make a mistake except with your subtraction or your doubling. So let's subtract now. 9 minus 0 is 9, and 6 minus 5 is 1. So now, if I look at just the 1, there isn't any number that will divide evenly into 1 without going over. So I'm going to look at the 19 altogether. And the closest number to 19, if I do 20, that's too big. 10 will go into it. Oops. So I'll write 10 underneath it. Now, that 0 isn't a 0 I annexed. It's a 0 that was part of the doubling. So I'm not annexing any zeros on this one. But I'm going to take that 2 next to the 10 and write it over here because I'm not annexing a 0. I'm going to put it in the 1's place. It's just a 2. It doesn't have a 0 after it. That was my husband sneezing. Now, I'm going to subtract again. 9 minus 0 is 9. 1 minus 1 is 0. So now I'm looking to for the closest number to 9 without going over. 10 is too big, so I'll use that 5 up there again. Now I'm going to take the 1 next to it. I didn't annex any zeros. Kind of far away. There's my 1. I'm going to write it over here. Now I'm going to subtract. 9 minus 5 is 4. Now, there is no number that will divide evenly into 4, so I'm just going to leave that there for right now. And I'm going to add up all of these numbers on the right. 0 plus 0 plus 2 plus 1 is 3. And 8 plus 1 is 9. This is my quotient. Now, when I look at this like a regular division problem, I know that 5 will not go into 4. You can't go into a room that's smaller than yourself, and 5 can't go into 4 either. So I'm going to put a little X right there so we don't put a number there. But that 93, I'm going to line up over the last 2 digits. Now, this number down here is my remainder. That's an R if you couldn't tell. So I'm going to write remainder 4. Now, that is our quotient and the remainder, but I could come over here and check. 93 times 5. 5 times 3 is 15. Remember, I'm just multiplying the divisor times the quotient. 5 times 9 is 45, plus 1 is 46. And then I add my remainder. I have a remainder of 4, so when I add that, 5 plus 4 is 9. And 6 plus 0 is 6, and 4 plus 4 is 4. Look at that. It totally matches my dividend. So I know I got it right. So our checking strategy for division, even the crazy way, is exactly the same. Here is our first practice problem. 616 divided by 8. If you need to go back and watch the example to work this problem, go ahead and do that. Pause it and push play when you've worked it out and you're ready to see how you did. Take a risk here. You might surprise yourself and get it right. Did you write 77? This one didn't have a remainder. Let's see how we did that. So I've already written the problem in the house, and I also went ahead and wrote the doubling numbers down the side. And if you'll notice, those stay the same every single time. It's always 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8. That never changes. Now we just add the numbers, the divisors. So 8 plus 8 is 16. 16 plus 16 is 32. Some people even just add them right here. They'll write another little 16 right there and add them, or another 32 right here. I can do these in my head. So, oh, that was a pretty bad 64. I hope you can tell that's a 64 and not a 69. So let's go ahead and look at our problem. We're going to look at the 6 first, and 8 won't go into 6 at all. No number will, so let's put a little X there. So we're looking at this 61 right here. And we want the closest number to 61 without going over. 64 is too big, so let's use 32. And we'll just write that right under the 61. Now we take the number next to the 32, which is a 4, and write it over here. Now I have an empty place value position, so you guys always know what to do here. You annex a 0, right? And if I annex a 0 here, I have to annex a 0 over here as well. Now I can subtract. 6 minus 0 is 6. 1 minus 2, can't do that, so we'll put a little 5 right there. 11 minus 2 is 9, and 5 minus 3 is 2. Now that's a pretty big number still, but it's a lot smaller than 616. So let's see, we're thinking about our strategy of what would be easiest. The closest number to 29 without going over would be 16. So let's try that. Let's write 16 under 29. We'll take the 2 that's next to it and write it over here. I'm writing it in the tens place because I know I'm going to have to annex a 0 for that ones place there, so I'll annex a 0 for the ones place here as well. Now I'm ready to subtract. 6 minus 0 is 6, 9 minus 6 is 3, and 2 minus 1 is 1. So now I'm looking at the closest number to 13 without going over. 16 is too big, I'll have to use 8. Now, since I'm not looking at this 6 at all, when I write my 8, I'm going to put it in the ones place as though that 6 weren't even there. So I have a 1 next to the 8. I'll write it here because I know I have to annex a 0 here. And I'll annex a 0 here as well. Subtract. 6 minus 0 is 6. 3 minus 8, can't do it. 13 minus 8 is 5. Now, the number that I have left over down here is getting closer to my doubling numbers. So the closest number without going over is 32. So I'll write 32 right here. I don't have any numbers to annex or any place value positions that I need to fill with a 0, so I'll take that 4 and write it in the ones place. And that means I'm getting close to getting finished, so that's always fun. 6 minus 2 is 4. 5 minus 3 is 2. Now I'm looking for the closest number to 24 without going over, and that is 16. And the number next to that is 2. Again, I'm writing that in the ones place. So 4 minus 6, can't do it. 14 minus 6 is 8. Let's see, closest number to 8 without going over is 8. And the number next to the 8 is 1. Now you can see the big mistake I might make is to forget to write this doubling number that's next to my doubles numbers I'm using. If I forget to write one of those numbers over there, my answer is going to come out wrong. So I'll have to make sure that I'm very careful about that. 8 minus 8 is 0. And now I'm ready to add up all of these. By the way, whenever the number down here is 0, that means I'm not going to have a remainder in this one. 0 plus 0 plus 0 plus 4 plus 2 plus 1 is 6, 7. And 4 plus 2 is 6 plus 1 is 7. So I know my quotient is 77. And that's really quick to check. 8 times 77. 8 times 7 is 56. 8 times 7 is 56 plus 5 is 61. And that matches my dividend perfectly, so my quotient is 77. It's time to challenge yourself. We only worked 3 practice problems tonight, so some of you may still have some things that you want to work on in the classroom tomorrow before you feel ready to attack those problem-solving questions in the textbook. But for those of you who think you've got it, let's try this. Take that crazy way of dividing and use it to divide by double digits. In this case, you're going to use the crazy way to divide 1,578 by 60. I think you will find it really easy to do using the crazy way. Show your work in your flip journal and come back tomorrow ready to check your answer in class. We're actually going to go over it as a full class just to see if it made it easier for you. Finishing up, I know this is something brand new and it's something your parents probably can't help you with, but it is just such a fun lesson that I don't want you to give up and I don't want you to think that you can't do it. It's something that will take a lot of time and a lot of practice, but once you get it, you're really going to enjoy it. Right now, write down in your journal if you think you're at a level 1, 2, or 3 in your learning. Remember, a 1 means I don't think I could work this problem without help. 2 is, I think I could do it, but I might make a mistake. And 3 is, I've got it. Go ahead and write down any specific questions you have, like how did you find that crazy number? And I can't wait to see you tomorrow. You've completed lesson 4-5, part 2, dividing using doubles division.